Hello. Today's target is students will use the Pythagorean theorem to find the length of the hypotenuse of a triangle. And make sure you have all the stuff you need on the board. It says you need notebook paper, a worksheet, a calculator, your Chromebook, and headphones, which probably you already have out if you're listening to this right now. So, before we can do this, we have to figure out what some of these things are because we might not know all of them. So, students will use the Pythagorean theorem. Let's figure out what that is. The Pythagorean theorem is a squared plus b squared equals c squared. It always is. That just is what it is. So, over here on your worksheet, you should put your name at the top because otherwise I don't know whose paper it is. So if you haven't written your name right here, I will pause for just a second. Write your name on your paper. Then over here at the top, we're going to write this because we're going to use it the entire day on this whole worksheet. A squared plus b squared equals c squared. And everybody just wrote it with me on their worksheet, right? So, students will use the Pythagorean theorem, we know what that is now, to find the length of the hypotenuse of a triangle. So we know what triangles are. So we're just figuring out what this word hypotenuse means. The Pythagorean theorem only works when we have right triangles. That means a triangle with this little box in it. That means we have a 90-degree angle in a corner here. If it doesn't have this little square, it's not a right triangle, and we cannot use the Pythagorean theorem. On this worksheet for today, all of them are right triangles. It's supposed to be like that. But we need to figure out what this hypotenuse thing means. So on a right triangle, where this little square is, there are two sides of your triangle that touch that corner with the square in it. Both of these are legs. So this one's a leg, and this one is a leg. So you have two legs that you walk on. Triangles also have two legs. The other side, the side that's opposite your 90-degree angle, or the side that does not touch that one, is our hypotenuse. So if you want to write this diagram on your paper, you can if you want, but we just need to remember that the hypotenuse is what we're finding today, the length of this side, and so we're going to use these two legs to find that. In Pythagorean's theorem, a squared plus b squared equals c squared, these all apply to our triangle. The legs are a and b. It doesn't matter which leg is a, and it doesn't matter which leg is b, but a and b always go with the legs. So I'm going to call this one a squared. Well, I'll just call it a. Sorry, a. This one's b. And our hypotenuse here is always c. Forever and ever. Amen. Always. So c is our hypotenuse, and a and b are legs. So the other thing on the other side of the equal sign here, that's what we're going to be finding today, the hypotenuse. So on your worksheet, you need a piece of notebook paper because I promise there's not enough room to write everything you need to write on here. So we have all these triangles. So I can tell right now, here's my corner that's 90 degrees. These two are going to be legs. This one's my hypotenuse. I can look down here on this one. These two touch the 90-degree angle. So these are my legs, and this one's my hypotenuse. Over here, next to this building, my 10 and 24 are my A and my B. Doesn't matter which one's which, but they have to be A and B. And this longer side here that's not touching that is going to be the C. So let's read the directions. Work each problem and find your answers at the bottom of the page. Shade out the letter above each correct answer. So if it's the correct answer, we're going to shade it out. We're not going to be able to see it. When you finish, the answer to the title question will remain. So whatever's left over at the bottom, that's going to be our answer to what do two bullets have when they get married. Find the length of the hypotenuse, we know what that is now, of each right triangle. If you want above hypotenuse here, you can put a little C, because that's our C on our triangle. So for number 1, on your notebook paper, 1A, we need to do A squared plus B squared equals C squared. So my two legs are A and B. So I'm going to, it doesn't matter which one's which, but I'll just make A this one. So A is 9. So you're going to put it in where the A is. We still keep the squared. Nothing changes about that. Plus my B is 7 equals, we don't know what C is, but we still have to put C squared because that's what we're finding. We still have to keep it A squared plus B squared equals C squared, even if we don't know what C is. So now you can use your handy dandy calculator. So 9 squared is the same thing as 9 times 9. So we get 81. 7 times 7 is 49 equals C squared. We haven't done anything with that C squared yet. It still just is like that. So now we need to do 81 plus 49. Oh my goodness. 81 plus 49, we get 130. 130 equals C squared. Now we've done a lot of things with 1 and 2-step equations, but now we have to undo something that is squared. And something squared is something times itself. So the way we're going to do that is we're going to take the square root, get it? Because this is squared. We're going to take the square root of it. So we're going to take the square root of 130 equals the square root of C squared. And over here, this becomes C. The square root of something squared is itself. The square root of 9 squared is going to be 9, just like the square root of 81 would be 9. So now this 130, with these little blue calculators, you have to type in the number first, and then you're going to use this key right here, this one that has this square root button on it. And it's going to tell you that you get this crazy answer. So we could do 11, we could round it to one decimal place, 11.4. And that would be the length of this side on our triangle, 11.4. But there's something interesting about this worksheet. If you look at the bottom, they have given you the answer you would get if you did the square root. They also left the answer in the square root form. So as long as you know that that's what that, let's get out of the light here. That's what that button is for, and we'll be doing that on some other assignments. But for this assignment, you can leave it in the version with its square root. So we had the square root of 130 right here. So this is what we got for 1A. So we're going to cross it out. So up here on your paper, I would write, in case something goes wrong, you need to go back and look, I would put the square root of 130. So we got for our answer. So on problem 1B, we still need to do the Pythagorean theorem. A squared plus B squared equals C squared. So last time we did A on the bottom and B for this side one, so we'll switch it up. A, B, and C is the hypotenuse, not touching that corner. So my A is 5. So we have 5 squared plus 11 squared equals C squared. On this whole worksheet, since we're finding the hypotenuse, it's always going to be something squared plus something squared equals C squared, because that's what we don't know, it's the side C. 5 squared, we know is 25, but if you want, we can type it in. 5 times 5 is 25. hopefully, maybe you remember what 11 times 11 is. 121. So we did the square root of a, square root of 11 equals c squared. We haven't changed that yet. So 121 plus 25, 146 equals c squared. Now to figure out what they each are, the square root of 146 equals square root of c squared. So c equals, in this case, we don't have to come up with a number, we can just leave it. By doing this, that's how we get rid of the square root. So now we just have c, the square root of 146. We could, if we could, 146, it would come out to be that lovely number. And if you want to write 12.083045 on your paper, you are more than welcome to. So we're at the bottom, we're looking for square root of 146 over here. So we're going to cross out this u. And up here, just so I remember in case something goes wrong and I need to fix down here at the bottom, I remember what my answer was. Square root of 146. Okay, C and D, I think that you guys can do on your own. I want to do one of these ones that's a word problem with you guys on this video. So let's do number 2. A rectangle is 3 meters wide and 10 meters long. How long is the diagonal of the rectangle? I believe in pictures. I think they're awesome. So I'm going to draw a picture. So I have a rectangle. Ta-da! That is 3 meters wide. That's the short side. Wide, 10 meters long. And actually, on these, I probably should have put centimeters. Yeah. So 3 meters, 10 meters long. And it wants to know what is this diagonal all the way across. So if it's a rectangle, it has to have 90-degree corners. So these are my 2 legs, and this is my c, my hypotenuse that I don't know. So a squared plus b squared equals c squared. I'm going to use 3 for my a, 10 for my b equals c squared. 3 squared, we hopefully know is 3 times 3, which is 9. 10 squared is 10 times 10, which is 100 equals c squared. 109 equals c squared, we're just adding them. Square root of 109 equals the square root of c squared. So the square root of 109 equals c. So over here, I'm going to write it up here so I don't forget. Square root 109. And then down here at the bottom, looking for 109. If you want to try to get the decimal answer and check it, you can do that too. It's got it on there. So that one's another rectangle. Number 4, I won't do the whole thing with you, but we'll talk about it. So a guy wire is attached to an upright pole. So here's our pole that's standing upright, and the wire attached to it is 6 meters above the ground. So that's where it's attached. So we know this length of our triangle is 6 meters. If the wire is anchored to the ground, so we're putting a stake in the ground and we're going to tie the wire down, it is 4 meters away from the pole, then how long is the wire? So this long side is our C. These 2 sides touch the right angle. So here are A and our B. Doesn't matter which one you use for A or B, but C is this other side here that we're going to find. Or same thing, a television. We have our wide and our high amount, and we're finding the diagonal, like we did on this one, the diagonal across that screen. Okay, at the end of this, you should be able to answer the question, what do 2 bullets have when they get married? And then by the end of today, you should have met our target for the day. We should all be able to use the Pythagorean theorem to find the length of the hypotenuse of a triangle. Thanks.